Okay. Now, let's suppose I give you $1,000.
Heck yeah.
Yeah. And not only that, I'm going to give you 100% interest.
So you're giving me $2,000?
No, that's not how interest works.
He's giving you so much per thing.
So, the first year, how much interest do you get?
100%.
100%. How many dollars of interest are you going to get?
Well, you gotta take the thing and do the thing.
100% of 1,000, right? Okay? So first year, the interest is 100% of $1,000, okay? So you have $1,000 plus $1,000. I mean, you'll have your money plus your interest, right? At the beginning, of your second year,
Wait a second.
okay? So how much interest are you going to get the second year?
2,000. Not 2,000. 4,000. man.
Second year interest is 100%. So you have $4,000 at the beginning of the third year, right? So if we draw a graph of how much money you have,
Just keeps doubling
we're going to let P stand for principal. That's what you call the amount of money you have, right?
it. Yes.
Okay? So you're going to start with $1,000. Then after 1 year, 2 years, 3 years,
4 years.
4 years, after 1 year, you're going to have $2,000. After another year, that's going to double. You're going to have $4,000. And then in the third year, you can see that you're going to get 100% of your $4,000, which is another $4,000. So you're going to have $8,000, right? So 8,000 is way up here. So we can kind of locate where this point is. Okay, what kind of a graph is this?
And
It's exponential. What's the doubling time?
A year.
1 year. Okay? Okay. Well, that's pretty generous of me, don't you think? Okay, well,
It's almost like if you get a penny.
you know, you got me in a good mood today.
We do?
Yeah, I'm gonna let you compound that interest twice a year. Okay?
100% twice a year.
No. I'm not that generous. And neither are banks. And neither are lending institutions, okay?
So 50%?
You 50% twice a year. Very
Because you
good.
just split it in half.
Well, let's see how it works. Okay, now. %, interest compounded twice a year means 50% after 6 months, and then another 50% at the end of the year.
But it changes.
What changes?
The amount of money you get.
Okay, what's it change to?
Well, the first year, or the first 50% is $500.
Yep.
And then the second one is $250. And I think maybe I did that wrong.
I don't know about the 250, but let's see. Let's work it
So
out,
you get
okay?
50%, you get 50% of your principal at 6 months, and then the other 50% at the
So
end
it'd
of
still
the
be
year.
1,000.
No, because you get 50% of your principal in the second half of the year, and your principal is $1,500, right?
Yeah. So you take.
So, we can work this out. This should be
Wait,
obvious now.
Wait,
Would you get 1,050?
so you get, wait, hold on.
Well, let's
So you
write
have
it out
1,000,
carefully. Go ahead.
and then 50% halfway through would be, you'd get $500. So by the end of the year, you have $1,500, and then you get 50% of that?
Well, after 6 months, you have $1,500, and I think everybody understands why
And
that
then you
is.
get 50% of that.
Yeah, you get 50% of this, okay?
Which is going to be $750. Huh?
Yeah.
And then if you go 1,500 plus 750, you get 22.
For the next 6 months, your interest is
So it should be 750.
So you end up with $2,250 at the end of the first year. Okay? Does that make sense? And then you just continue the same way. You keep adding 50% of whatever your principal is at the beginning of that particular 6-month period.
That's like if you have a penny and you get a penny a day, you'll end up with more money.
Well, penny a day would just be,
But it
That's
keeps.
365 pennies by the end.
Yeah.
You
But I
have
mean, like,
$3 by the end of the year.
for every penny you have, you get
Congratulations.
like it doubles. Does that make
okay,
sense?
you're on,
You know what I
you're on a
mean?
good track.
Every
Let's-
day it doubles.
Yeah, let's go back to this and continue thinking that way, though. You know, think about that and make sure it resolves with what we're doing here. Okay, now, my question is, then, what's the graph gonna look like?
I guess we're gonna have to draw it.
Well, the graph at the end of the first year is gonna have you up at 2250, right? Okay? And then, if you continue for another year, it's gonna be up here, it's gonna be up above this one, and your graph is gonna end up looking something like this. It's not intended to be very precise, but you get the idea, right? What's the doubling time of that curve? Is it more or less?
Less.
Okay, so you got a lesser doubling time. You can see the doubling time here. If we come out to this point and down here,
So you actually get more money.
A new T sub D, a new doubling time, right? That make sense? Well, now, we could compound this thing quarterly. Meaning you would get 25% every 3 months.
Okay.
And that has
After-
its advantages.
So after you already have the 22.
Well, we're gonna get a little more sophisticated with our model, because I don't wanna write out all these words anymore. But does everybody have the idea
Yeah.
of how this works? Okay? So, I'm gonna write this out. T is 0, 1/4, 1/2, 3/4, 1, right? Okay? And N is 0, 1, 2, 3, 4. N, actually, I don't want that to be N. Let's see. We'll call this M. And we might use that, and we might not. Think through this. This is coming out of your questions and so forth, okay?
Oh, 1/4, 1/2, 3/4.
Okay, well, anyhow, your principal, say is 1,000, right? Your principal here, okay, there's a jump that I want to make. I'm not sure it's a good idea. So I'm going to do it this way. Principal, interest, okay? So, $1,000,
What does the T and the M represent?
T's the number of years. A quarter of a year, a half a year, 3/4, 1. We're just gonna do 1 year for the moment,
What
and then we'll
does
extend
M
this.
represent?
Sorry?
What does M represent?
We don't worry about that yet. It'll come up. I said I'm not sure I'm even gonna use it in this iteration. I'm taking this through as I go, okay? So don't worry about M, but M increases by 1 every time. So M is the total number of times this thing has been compounded, right? In a year it'd be 4 times. And then we could continue, you know, we could go to 5/4, 5, etc. Okay?
So,
$1,000, what's my interest? Well, you know, it's $250, 25% of 1,000, right? Except what I want to write this as is $1,000 times 0.25. Okay? And now, realizing what I'm about to do, I want to put this column for the interest quite a bit further to the right because I'm going to need more room to write my principal. Okay, so my interest is going to be out here. $1,000 times 0.25. Okay, so now what's my principal going to be? It's going to be 1,000. plus 1,000 times 0.25, right? Okay, I don't want to write the numbers anymore. I want to write calculation. And I'm going to do another step where I symbolize it a little bit further, but I want to build up the symbolization because you're not that used to symbolizing things. Okay, some of you might be, but I'm not going to assume it. Okay, so now what's your interest?
One, yeah, what you,
It's what now?
1,250.
No, we're not going to calculate that.
2,000 times decimal 2.5.
Well, it's going to be this times 0.25, right? This is your new principal.
Mm-hmm.
You know that's 1250, but pretty soon you're not going to know what the numbers are. Because they're going to get complicated, right? So we don't want to write down the numbers. We want to write down the process. And you'll see why in a minute. So the way I want to write this down is, it's this multiplied by 0.25, isn't it?
yeah.
And I'm not going to write this as 1250 because I lose track of where everything came from. I'm going to write it as 1,000 plus 1,000 times 0.25 multiplied by 0.25. You're not used to seeing it like that because you're just calculating the numbers and stuff, which is more or less appropriate. Okay? So I don't have a big argument with that, but I'm trying to show you how we build symbolization, how we build the expression for an exponential function out of this. That's where we're leading. Okay, so now what's your principal?
1,000 plus
1,000
plus
1,000
1,000.
times 0.25 times 0.25 plus 1,000. How is this more understandable than just writing down the number?
Let me see the process. What we're doing.
I'm so confused now. I took both.
Wait, why did we add that? I thought that was the interest. Wait, I'm so confused.
Well,
Because you have to add interest.
here's your
onto it.
interest, which is added to your principal. Here's your interest, which is added to your principal, right? Here's the principal. You get
So
to
you
keep
just
your
drag it
principal,
down and then you add the
and now you
interest.
add your interest, okay? Now, see, the expressions are getting a little bit difficult to manage, okay? So what are we going to do about that?
I don't know.
Well, what we're going to do is we're going to develop a better notation. It's going to get too long to write down, okay? So one thing I'm going to do is I'm going to say this. Well, let's see. Okay, 1,000 plus 1,000 times 0.25. This expression could be factored. Anybody see how to factor this?
Pull out the 1,000.
Again?
Pull out the 1,000.
Yeah. You know, we've got 1,000 in common between these two things with a plus, right?
One.
So it's a simple factoring a monomial. You're probably not familiar with it because usually when you factor a monomial, it's a symbol. Or you got symbols, but here it's all numbers. Anyhow, so what do we get over here? 1,000 times what? 1 plus 0.25, right? Distributive law tells you clearly that these two things are equal. If you don't see it going this way, you can certainly see it going this way, because if I multiply 1,000 times 1 plus 0.25, I get 1,000 times 1, which is 1,000, plus 1,000 times 0.25, right?
This is where you get the formula from.
Huh?
This is where you get the formula.
Yeah, this is leading to a formula, okay? So, and this equals,
A equals P times 1 plus R over principal.
1,000 times 1.25. Okay? So now I can write this a little more compactly. I can write my principal here and my interest here. Now it's still 1,000, but now I'm going to write my interest as 1,000 times 1.25. Instead of writing out, sorry. Yeah, my interest would still be 1,000 times 0.25, but now I can write this 1,000 down as 1,000 times 1.25. Okay? Now, I could write my interest here, but it becomes unnecessary to do it. I know what my next principal is going to be. Because I'm going to this step I should probably take. Yeah, okay, I'm going to write down another step here. Okay, now 1,000 times 1.25 plus 1,000 times 1.25 multiplied by 0.25 is equal to what?
What?
What can I factor out of this?
1,000
1,000
and 1.25.
Yeah, I can factor out 1,000 times 1.25.
Because there's two of them.
I can write it this way, can't I?
Yeah.
And of course I can write this. How can I write this a little more compactly?
I don't know.
Well, what's 1.25 times 1.25?
3, wait.
No, don't calculate it. Tell me what it is. What's 1.25 times 1.25?
1.25 squared.
Yeah, 1.25 squared. Right? Okay? So I'm going to cross out this column. It's going to be unnecessary. Okay, 1,000 times 1.25 squared. Okay? Because every time I add 0.25, it's the same as multiplying by 1.25, isn't it? Which means, what's my next one going to be?
2.
Yeah, I'm going to multiply it by 1.25. Okay? And now I have an expression and now I can use my m. M is just the exponent over here, isn't it? Okay? So in general, this is always going to be 1,000 times 1.25 raised to the power m.
So P equals that?
So what?
P equals 1,000 times 1.25 raised to n.
Yeah. But then m is related to t. Well, actually, M is related to the number of times you compound this thing, okay?
So 1,000 is just when we're dealing with quarterly? We use 1,000 every time, or is that?
Well, 1,000's just the principle that we use because it's a nice round number and it was easy to do calculations with.
But
We're
when
gonna
we
do
it
the whole
ourselves,
thing in
we can
symbols in a
change.
minute. Okay? Did I answer your question? Doesn't look
So
like
when
it.
when we have our own problems, will we have 1,000 or will we have just any number?
You can have any number,
Okay.
That's just how much money you put in the bank.
okay?
Just think of the paycheck.
But, no, my big point is, what's M
How many-
over here? How's
Year.
M related to T?
The amount of times you compounded.
How's M related to T? If I give you T,
The amount of years.
in other words, if T is 17 and a quarter years, what's M?
You would have
Multiply by 4.
you would have compounded it.
Yeah. M is 4 times T, right?
Mm-hmm.
Yeah. If I multiply 1/4 by 4, what do I get?
68.
1. If I multiply 1/2 by 4, what do I get?
2.
3/4 by 4?
3.
Great.
Okay, so M is just 4T. Okay? We see that?
Yes, sir.
So, big deal. P of T, function notation. Principal as a function of T is $1,000 times 1.25 to the T, to the 4T.